Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're going to take a look at graphing quadratics in our different forms, and we're also going to take a look at how to put an equation into standard form. So when we deal with our quadratic equations, our quadratic functions, we've got three different forms. We have intercept forms, which is what we worked with yesterday. When I say intercept form, I want you to factor it. We have standard form. Standard form, y is equal to ax squared plus bx plus c. When I ask you to put something into standard form, I want you to multiply it out. And then we have vertex form. Vertex form, we're going to get into a little bit tomorrow. If we want to put something into vertex form, we want to complete the square. So let's practice moving from one form into standard form. Again, if we want to put something into standard form means to go ahead and to multiply it out. All right, so looking at number 1, I have that in intercept in factored form right now. Y is equal to 2 times x minus 1 times x minus 6. I want to start by foiling this together. So I've got that this is 2 times x is going to give me x squared. The outside is negative 6x. The inside is negative 1x. So that's going to give me a negative 7x. And then negative 1 times negative 6 is going to give me a plus 6. I want to be able to distribute the 2. So I'm going to have y is equal to 2x squared minus 14x plus 12. And I've gone ahead, I've put that into standard form. Now if we take a look at number 2 is in vertex form. Again, I want it to be in standard form. I need to multiply it out. Now one thing I want you to think about, 8x minus 1, all of it squared. Do I square the 8x and square the 1 and say, woohoo, I'm done? Hopefully you're saying no. 8x minus 1, all of it squared, really means 8x minus 1 times 8x minus 1. So we've got to FOIL it out just like we did with that first one. Let's go ahead, let's do that. I've got y is equal to 1/2. Now 8x times 8x is going to give me 64x squared. The outside is negative 8x. The inside is negative 8x. That is a negative 16x. And then negative 1 times negative 1 is going to give me a positive 1. And then after that, I'm going to subtract the 3/2. Now I need to distribute that 1/2. That's going to give me 32x squared minus 8x plus 1/2, and then minus 3/2. And I want to combine like terms. That's going to give me y is equal to 32x squared minus 8x, and then 1/2 minus 3/2 is a negative 2/2, so that is a minus 1. And I've got ahead, I've put it into standard form. So again, standard form means we're going to multiply it out. All right, so now we're going to start taking a look at our exact graphs of some of these quadratic functions. All right, for each of these, I want to be able to find all of this information. I then want it accurately graphed on the grid. How many points do you put on the grid? All the ones that will fit, okay? I want all integer values that will go ahead and fit on this graph. So let's take a look at the equation. I have y is equal to x squared minus 2x minus 1. This right here, this is my standard form. This is y is equal to ax squared plus bx plus c. All right, and just by looking at this graph, if I take a look what my a value is, notice in this case, a is equal to 1. That a is equal to 1, we know how to deal with an a value. An a value will tell us if the graph is going to open up or down. Since this is a positive 1, we know that the orientation is going to be up. Since it is a 1, we know that the shape is going to go ahead and it's going to be normal. We're going to be able to get one other bit of information from this just by taking a look at this equation, but I'm not going to tell you what it is just yet. All right, from here what I'd like us to do is I'd like us to take this equation, I'd like it to plug it into y1. Let's pull out our calculators, and into y1 I would like the equation x squared minus 2x minus 1. And I want to go ahead and I want to graph that. All right. Now I can go ahead, I can figure out what the vertex is going to be, what that lowest point is going to be by doing second trace and looking for my minimum value, which is number 3. Tells me to arrow to the left, click enter. Tells me to arrow to the right of it and click enter. And tells me to go ahead and to take a guess. Now my calculator is having a little bit of rounding issue, but I'm seeing that my minimum value here is 1, negative 2. That is what my vertex is. 1, negative 2. Let's put that on our graph. Notice we were correct too. Does the graph open up and does it have a normal shape? It does. We want to be able to go ahead and find some other points on this graph as well though. To do that, let's go ahead, let's take a look at our table. If we click second graph, you may need to arrow up or down to go ahead and to find your values, but I can go ahead, I can see I've got some other points that are going to go ahead and fit on this graph. I have the point negative 2, 7. I have the point negative 1, 2. I have the point 0, negative 1. Notice that my point 1, 2, or 1, negative 2, which was my vertex, that was there. And then the graph goes up for the other arm in a symmetrical way. So I have the point 2, negative 1. I have the point 3, 2. And I have the point 4, 7. All right, from here I can go ahead, I can connect my dots. I should have some nice arrows on the end. And I have my parabola that I just went ahead and I formed there. Now, I have the first 3. I want to talk about the equation of the axis of symmetry. The equation of the axis of symmetry, well, the axis of symmetry is a vertical line that goes straight down the vertex. Since it's a vertical line, we know that it is x is equal to a number. And since it is passing through the vertex, it's the x coordinate of the vertex. It is x is equal to 1. Now I also want to know what my y-intercept is. Keep in mind to find the y-intercept, you can always take a look at what the table says where x is equal to 0. In this case, x is equal to 0 and y is equal to negative 1. So my y-intercept is at 0, negative 1. Now, do you remember how I said we were going to be able to find one more piece of this information just by taking a look at our equation? Well, let's look at what our c value is. That c value is going to tell me what my y-intercept is. Because let's think about it. If I plug 0 in, I have 0, 0, and then minus 1. Well, 0 minus 0 minus 1 will give me the negative 1. The c value is always going to be your y-intercept when you're in standard form. Now I also want to be able to figure out what my x-intercepts are. So to do that, I'm going back to my graph, and then I'm going to find the one that's on the left-hand side here first. Second trace. Another name for an x-intercept is a 0, so number 2. And we're going to go ahead. We're going to arrow to the left and click enter. We're going to arrow to the right and click enter. And then we're going to take a guess. And I see that my first 0 is at negative 0.4140. So there's my first x-intercept, negative 0.4140. Let's find the second one, second trace. Number 2, we're going to go ahead, we're going to arrow to the left of it, click enter. We're going to arrow to the right of it and click enter. And we're going to take a guess, and I see that my other 0 is at 2.4140. All right, so when we are in standard form, we can find the orientation, we can find the shape, and we can find the y-intercept just by taking a look at that equation. All right, let's go ahead, let's flip it over. Let's take a look at the second one. This second one here, this is in vertex form. Y is equal to a times x minus h squared plus k. Now, from this one, we know our A value. Therefore, we know the orientation and we know the shape. Since it's negative, it is opening down. The absolute value of 2 is bigger than 1, which means that our shape is going to be stretched. We know what our vertex is. Our vertex is -3. -2, again, it's the exact same thing it was for our absolute value. And since we know the vertex, we also know what the equation of the axis of symmetry is. X is equal to -3. So I'm going to go ahead, I'm going to plot that vertex. I know it's right there. And I'm going to go ahead, I'm going to put this into my equation then, into y1. I've got -2 times the quantity x plus 3, all of it squared, and then -2. And let's graph it. Were we right so far? It opens down. It is stretched. It's not as wide as the normal graph. And I am seeing that the vertex is in that general vicinity of -3, -2. So let's go ahead. Let's take a look at the table then. And I want to be able to plot some other points. I have -5, -10 that I can go ahead and plot. I have the point -4, -4. I have -3, -2, and then you can see that it is symmetrical going down the other side. So I have -2, -4, and then I have -1, -10. All right, we want to be able to find the y-intercept. To find the y-intercept, we look where x is equal to 0 is on our table. We see that the y-intercept is going to be 0, -20. And if we take a look at this, we've got our x-intercepts. Well, does this graph ever intersect the x-axis? It doesn't, which is why we have none for our x-intercepts. So the next one I don't want to go ahead and rush through, so go ahead and find me video 2, please.